Okay, Algebra 2 students, here's the first video for section 3.3, polynomial identities. In this section, we're going to see how we can use polynomial identities to rewrite expressions efficiently, vocab, binomial theorem, identity, and Pascal's triangle, and in the end, you're going to be able to prove and use polynomial identities. It'll kind of be a shortcut if you can see the pattern. There's an activity on Pascal's triangle that maybe your teacher did or will do with you. I'm going to go right to the examples. First, we have all these polynomial identities. A mathematical statement that equates two polynomial expressions is an identity if one side can be transformed into the other side using mathematical operations. These polynomial identities are helpful tools used to multiply and factor polynomials. So these are things you're going to want to understand. The first section has us prove them, so your teacher may even skip this video. The difference of squares, a squared minus b squared, can be factored into a plus b times a minus b. The square of a sum, if you have a plus b, that quantity squared, it's going to equal the first thing squared plus 2 times the two terms plus the last term squared. The difference of cubes, if you have a cubed minus b cubed, you're going to have that factors into a minus b times a squared plus ab plus b squared. And the sum of cubes, if you have a cubed plus b cubed, you're going to have a plus b times the quantity a squared minus ab plus b squared. And hopefully they give us some problems that help us practice how to break those down. For example, if we had to break down g cubed plus 64h cubed, we could automatically apply this to it because g cubed is cubed and 64h cubed is a cube. So I can break down to this. All right, let's see what they're going to have us do. I think they're going to have a prove the polynomial identity. How can you prove that this is actually an identity? Well, you just do the multiplication out on that, and if it equals this in the end, then it proves it. And that's what they did. I'm going to save time here by not going through it all, but you can click pause and look through it. This times this, they distribute, they combine like terms, and they got that. Therefore, it was a proof. They want you to prove the difference of cubes identity, which looks like this. So if you want, click pause, come on back, and I'll show you the answer. I'm not going to show you all the steps, though, because we really care that you're just able to apply them, not necessarily prove them. Here's all the steps for that. And there's only one homework problem that your teacher may assign to you, and that's number 27. Have a great day.